All right, let's take a look at density calculations, part A and B. And to do that, I'm going to make things a little bit larger in terms of what we're actually going to look at here. And second of all, I'm kind of in a semi-public place here, so I don't want to disturb the entire world here. So I'm whispering, and I'm really hoping that you can pick me up. A particular brand of gasoline has a density of 0.37 grams per milliliter at 25 degrees Celsius. How many grams of gasoline would fill a 16-gallon tank if 1 gallon equals 3.78 liters? Well, the first thing you always want to do is remember the words of chemistry cat. Whenever you see a divided unit, most of the time you're going to use it as a unit conversion. So when we have a density, we treat density really like it's any other unit conversion. This one relates volume to mass. We then have one other number in our problem, 16 gallons. So that's the number I'm going to start working my problem with. So I've got 16.0 gallons. I have no idea how I'm going to solve this problem. I don't even remember what they're asking for. But I know that if I'm starting out with units of gallons, my first step is always going to be to get rid of it. Whatever number I start with, I'm going to place down here in a position where it cancels out. So let's see. First of all, let's see, where are we trying to get to? We're trying to get to grams of gasoline here. Let's see, I don't know a quick way to go from gallons to grams. So let's see, what can I do? Hey, I know a way to go from gallons to liters. I know that 1 gallon is 3.78 liters. So we've got that, so it cancels out. Now we have liters. Are liters what they're asking for in the problem? No. So we know our next step, since liters isn't what we're being asked for, is going to be to cancel out our liters. So we've gone from gallons to liters, and now we want to get rid of liters. What do we know about liters? Well, the problem doesn't give us anything about liters. Let's see, does the problem give us anything about a unit related to liters? Yeah, milliliters. And we've memorized, and if you haven't memorized them yet, shame on you. You really need to do that. If you don't memorize your metric conversion factors, your entire life will be hampered. It's the one thing I hate about this class, is that I have no way to actually enforce the memorization of these facts easily. But you'll struggle all semester if you don't have things like this memorized. That 1 milliliter is equal to 10 to the negative third liters. If you haven't memorized those metric prefixes, stop what you're doing right now. Go back and do so. Really, I'm begging you here. All right. So we know something about liters. We place milliliters on top where they'll be left over. Liters where they'll be left on the bottom. Keep the numbers with their units. There's a 1 in front of the milliliter. There's a 10 to the negative third next to the liters when we wrote the relationship. So now we have milliliters. And we've canceled out our liters. Well, milliliters aren't the units we're looking for, so we know we're going to have to get rid of them. Do we have a relationship between milliliters and mass? Hey, yeah. That's what this conversion factor up here is telling us. So if we look here, we know that 1 milliliter is equivalent to 0.737 grams. Hey, grams are the unit I'm looking for. Therefore, I must be done. So I'm going to multiply everything on top, divide through by everything on the bottom. 16 times 3.78. Divide by 10 to the negative third. Wow. Okay. I'm getting a huge value there. as well I should actually. Let me double check that though. Got 16 times 3.78 divide by, come on, my calculator's not wanting to work. Just a second. Sorry, guys. For whatever reason, I left my calculator at home, and I'm forced using the stupid iPhone calculator, which is just evil and bad when it comes to actually doing anything, and it's not letting me rotate. Okay, so the lie your calculator gives you is 44,573.76. Now we have to apply sig figs. We've got 3 sig figs there, 3 sig figs there. That's exact because it's by definition. That's measured, and that's 3 sig figs. So it looks like we should have 3 sig figs here. 1, 2, 3. We'll round on the basis of the 7. So that means we've got 44,000. That 5 is going to become a 6. 600. We could put this in scientific notation. 4.46 times 10 to the 1, 2, 3, 4 times 10 to the 4th. And our units would be lowercase g for grams. So that's that one. Now let's take a look at the second one. A block of metal has a width of that many centimeters, a length of that many centimeters, and a height of that many centimeters. Calculate the density of the metal, and they want you to use appropriate units. Remember that for density of a solid, your standard units should be grams per cubic centimeter. So we've got 2 problems in order to get the density for this. First, density equals mass over volume. So we need to solve for the volume in cubic centimeters and the mass in grams. Mass in grams is going to be pretty easy. They gave us a mass of 1.2 kilograms. So we can solve for that right away. And 1.2 kilograms. We want to get rid of kilograms. Hopefully you've memorized that 1 kilogram equals 1,000 grams. If you haven't memorized it, again, crisis time, you need to memorize them. So we've got 1.2 times 10 to the 3rd grams as our mass. Now we need our volume. Volume, remember, is length times width times height. So 3.2 centimeters times 17.1 centimeters times 4.4 centimeters equals 3.2 times 17.1 times 4.4 equals a calculator lie of 240.768. Now, that's the number your calculator gives you, but you've got only 2 sig figs. This is where we're going to use that drop-down technique. Remember, to avoid propagation of error, what I'm going to do is I'm going to write 240, and then below the line, to remind myself that they're insignificant, I'm going to write those numbers. Oh, and our units are cubic centimeters, because centimeters times centimeters times centimeters, cubic centimeter. So now we know our density is 1.2 times 10 to the third grams divided by 240.768 cubic centimeters. Multiply everything on the top, divide through by everything on the bottom. And that gives us that gives us 0.04064 as our calculator lie for the density of our metal. No, that's not right. Something's wrong here. What did I do wrong? My calculator's not working. Just a second here. Let me change my calculators here. 1, 2, divided by, it should be like 6 something, divided by 240.768 equals, there we go. Somewhere along the line I hit a wrong button in the calculator. 4.98405 is our calculator lie. Sig figs, we've got 2 there, 2 up there. So 1, 2, round on the basis of that. And that gives us 5.0 grams per cubic centimeter. Chemistry's easy, life is hard. Beep.